Hi guys, it's Mrs. Milson. We're going to do our last check your understanding for the year, and this is on page 757. This is a significance test for slope, okay? Now the previous check your understanding on page 752 describes some results from a study of non-exercise activity, NEA, and fat gain. Here again is the Minitab output from the least squared regression analysis of the data. Does the data provide convincing evidence at the alpha 5% level of a negative linear relationship between fat gain and NEA change in the population of healthy young adults? Assume that the conditions for regression inference are met. Oh, good, even though we already did it. So if we recall from the check your understanding on page 752, where we estimated the true population slope of the regression line that relates fat gain to change in NEA, we ended up with an interval that was positive to positive. So our confidence interval believes that the true slope is negative, okay? So we are probably going to come to that same conclusion from the significance test. Okay, so the first thing we have to do is our state, and of course we've got our ho and our ha, okay? As with all of our null hypotheses, the null hypothesis is always that there is none, there's no, it's the same, it's no change. So here we're going to say there's no linear relationship, but we'll put it in syntax of our letters. So we'll say beta is 0, because remember beta is the true population slope of the regression line relating fat gain to change in NEA. So basically with if a line has a slope of 0, it has no slope. It has no linear relationship. So I'm going to put that in parentheses. It means there's no linear relationship. Okay. Now the book says we want to see if we have evidence of a negative linear relationship. So of course my ha is going to have to be less than 0, because if beta is less than 0, it's going to have a negative slope. Okay. So according to our confidence interval, it does have a negative slope. So we're hoping we're going to be rejecting the ho. Okay. I need my alpha. I believe it gave me a 5% alpha level. I'll stick that over here. Alpha is 0.05. Okay. Thank goodness this says assume that conditions for inference are met. But we went through all the conditions in the last check your understanding. But we are going to write down, it says stated to assume the conditions for regression inference are met. I still want to put my plan here, okay? I'm still going to be doing a t-test for slope, okay? Still want to name the test, okay? And in the calculator, it's called linreg t-test, okay? So when in doubt, you can always look to the calculator to figure out which test it is or what the test is called. So linear regression t-test or t-test for slope. Okay, the do, so now I know it's a t-test, so I'm going to have to find my critical, or not my critical t, my t-score. And if we recall from doing significance tests on mean, the t-score is just the sample minus the mean of the ho divided by the standard deviation of the sampling distribution. Well, here, my sample slope is the one from my printout. That's the slope from my sample, okay? And then my slope from my null hypothesis, of course, is 0. So that's the first part of my t-score, okay? Actually, I should write that formula down. I'll write it over here so you can see it. So it's my sample slope minus the slope of my ho divided by the standard error of my linear regression, okay? Now that, again, is on the printout, okay? So if I come up here, just like I used it in my confidence interval, I'm going to use that standard error down here. Remember, don't use the top row, those 3 things, use these bottom 3. Okay, so there's my standard error. So I'll put, okay, and if I throw that in the, wrote my standard error. If I throw that in the calculator, I get negative 4.64 as my critical t. And of course, I can do TCDF to find my p-value, but you'll notice my critical t, my t-score, negative 4.64, is right there in my printout. So I don't really need to calculate it, okay? So I have my critical t, and lo and behold, there's my p. So again, use these ones on the bottom. So my p is essentially 0. Now, the thing you got to realize, in your printout, This p-value is for a two-tailed test. So the greater than, not equal to. So it would be the high end and the low end. So I would have to, since my alternative hypothesis is less than, I should take that p-value and divide it by 2. Now I realize it's 0, and 0 divided by 2 is 0, but I still think we need to note that. Okay, so the p-value on the printout is for a ha of not equal to. Okay, so since we have a alternative hypothesis of less than, I should take that and divide it by 2. So of course it's still 0, but please note that, because if that had been 0.01 something, you would have had to divide it by 2. Okay, so that's still my p-value. So let's compare p to our alpha, and of course at 0, it's going to be less than any alpha. So I know I can reject the hoe. So I know I'm going to have, if I reject the hoe, I have convincing evidence that the true population slope of the regression line relating fat gain to change in NEA is less than 0, or it is negative. Okay, so let me show you that. So my p-value of 0 is less than alpha, and it is statistically significant, okay, at that alpha level, so I can reject the hoe. I have convincing evidence that the true population slope of the regression line relating fat gain to change in NEA is less than 0, or it is negative, okay? And that's exactly matches our confidence interval, okay? Because remember, our confidence interval ended up with an interval from negative to negative. So it makes sense that I would reject the hoe and have evidence for a negative slope, okay? I believe that is it. Okay, see y'all later.